All right, we're going to do a inverse Laplace transform here. This is our function. We'd like to find the inverse Laplace transform of this capital Y function here. There's two relevant lines from our Laplace transform table that are listed here for our reference. We're going to need these. We kind of are looking at the right form. We have an s plus 2 squared plus 9, so we have an s minus a squared plus k squared. We have the right denominator, but our numerators don't match what's in the table. And so we're going to have to work on this a little bit. And this is our add subtract trick to force this into something that fits the table. And if it's going to fit the table, we want the same s minus a that we have in the denominator. We want that in the numerator. So the same s plus 2 we have down here, we're going to want that upstairs. So I'm just going to force it. And at first it's cheating. Instead of s, I'm going to write s plus 2. That's not true, right? This is not equal to this. So I have broken some rules here, but I do have an s plus 2. How do I fix what I broke? What I really did is I added 4 times 2. I added an 8. So I'm going to subtract an 8. And now these two really are equal. So this is the add subtract trick. I've added 8, I subtract 8, and I did it so that I can have the s plus 2 to go along with the s plus 2 in the denominator. So what this really looks like is 4, and then s plus 2 over s plus 2 squared plus 9 minus 13. Actually, let's put that down here. Minus 13, 1, s plus 2 squared plus 9. This is now in line with number 17 in the table. I have it in the right form. This is not quite there. I need a k to go with the k squared. So I have a 9 here. I need the numerator to be a 3. So I use the multiply divide trick. Multiply and divide by 3. And now I have 13 thirds. And then I have a 3 over the s plus 2 squared plus 9. I am now ready to use the table to invert this thing. I have little y of t. I have the 4, and then the inverse of this is a cosine. It's e to the minus 2t cosine 3t. And then I have a minus 13 thirds e to the minus 2t sine of 3t. And that is our inverse, and that is the add subtract trick. And we use it when we have the s minus a in the denominator and we need a similar s minus a in the numerator. We add and subtract the same quantity. It doesn't change the quantity, but it changes how it looks. We multiply and divide by the same quantity. Again, doesn't change the quantity, but it changes how it looks so that everything fits the table and we can get the right inverse.